Welcome back to another GIS lecture video. And in this lecture video, I want to continue our discussion talking about this idea of weighting a spatial center. So in the previous video, we talked about weighted mean, and we saw that if we wanted to incorporate some sort of attribute into the calculation of our mean, we altered the equation to multiply the coordinate by the weight, sum that up, and then divide by the sum of whatever our weight was. Now, if we remember back to our discussion talking about the other two options, right, median and central feature, we would recall that both of those hinged on the use of that Euclidean distance, right? And it was trying to find either a theoretical point or an actual feature that had the shortest possible total distance to all the points, right? That was the most accessible feature. And so we can alter that distance equation similarly to the way that we altered this mean to include some sort of attribute. And so I'm not going to go through I'm not going to repeat how the process works for median and central feature because it works the same, right? We're summing up those distances and then finding the one that has the least. But what I do want to go over is how we alter that Euclidean distance equation to be weighted. So I'm going to give myself a little bit of space here, and we're going to talk about this idea of weighted Euclidean distance. Weighted Euclidean distance. Okay. And so we're going to start off with the equation that we had before, right? That this distance d was going to be equal to the square root. I'm going to leave some space up in the first part of this here. But that we had this idea of taking the x-coordinate of the first one minus the x-coordinate of the second one, squaring it, doing the same thing to the y's, right? y1 minus y2 squared. Right, so this is our original distance equation that we've dealt with before. So what we're going to do to weight it is much the same way that we weighted the mean. We're just going to multiply this whole thing times whatever weight we have for that point. Right, so we're going to calculate the distance just like we did before, and then we're going to multiply it by the weight of whatever feature it is we're trying to weight, right? And so in this case, right, if we were trying to calculate the central feature, right, what we would do, one of these x's would be the feature that we're holding constant, right? Whether we were assuming that this was the center, right? Let's assume this was the center, right? Actually, let's diagram this out, right? Let's assume that this was the center right here. What we would do is we would calculate the distance between this point and let's say this point here. We would calculate this distance here. But we would multiply it by the value of this point here, right? So that the more important that this point was, right, the higher this value would be, right? So we're basically artificially making this distance more important by calculating in or including in the weight. Okay, so that's all this is doing. It's doing the same thing as it was here. It's saying, hey, we can include the weight by multiplying the distance times the value so that features that are features that have higher attributes are going to be given a stronger weight. Hopefully this makes sense, and if you have any questions, as always, please reach out. Thank you.